Okay, guys, in this video, we are going to take a look at the spherical coordinates and how we set up limits of various 3D shapes using spherical coordinates. So first of all, what are spherical coordinates? So here you see a picture of a sphere with radius 6. And imagine that you take a point on the sphere. So just take one point on the sphere. So let's just say it's this point right here, and let's call this point P. And then this is the origin. And so if you connect the origin with point P, okay, with the line segment, you will get something called rho. So in spherical coordinates, rho is the distance from the point to the origin, okay? Then if you were to drop a perpendicular on the z-axis, right? And so it's going to be a little bit at an angle because I'm drawing in 3D, but it's going to be something like this, okay? So this is going to be the right angle. And this side, this particular side, that's your z. Okay, so how do I find that z? Well, the angle phi, phi, that's the angle between the line segment OP and the z-axis. So from the just the property that cosine phi is the adjacent side divided by the hypotenuse. So this is going to be z divided by rho. And so z is going to be rho cosine phi. So that's your first connection between phi, rho, and theta and xyz. Okay. Then we also need to figure out what about x and y. So this is going to be a little bit more complicated. So what's going to happen here? So first of all, I'm going to draw another right triangle. So if I were to draw the triangle until it like hits the xy plane, right? So, and then draw this right here. So this is basically going to be this side right here is going to be the same as this side, right? But what is this other side? So this other unknown side, and then also this is here. So this red side, we're just going to say red, whatever, this bottom red side, what is that? So for using the same triangle, you can say that sine phi equal, now this red side, right? Which is the same as the top over here. So it's going to be red over rho. So the red side is going to be rho sine phi. Okay, so that's rho sine phi. And then what is angle theta? Well, angle theta is the angle with the x-axis. So this is angle theta. Okay, so if you can also imagine another right triangle right here, right? But let me also draw it like maybe over here somewhere so that now it's in 2D. So what's happening with that? So this is x, this is y, right? And the angle theta is the angle with the x-axis. So this is your triangle, right? So this is angle theta. And how do we find x and y? Well, if we knew the hypotenuse, but the hypotenuse is the red side. This is rho sine phi. This is rho sine phi right there. Then we know that x equals hypotenuse multiplied by cosine of theta. So this is going to be rho sine phi cosine theta. And y is going to be rho sine phi sine theta. Okay, that's the connection. Also, you can show that, which I'm not going to show right now, but you can show that in spherical coordinates, x squared plus y squared plus z squared equals rho squared. So that's the connection. Okay, so now let's see if we can set up the limits. So first we're going to have the sphere and we want to set this up. So I'm going to have this next to what we're trying to set up here. Okay, so first question, how does rho change on the sphere? So rho is the distance, right, from the point to the origin. So this distance right here. And because this sphere has radius of 6, this is going to change from 0 to 6, right? So you are moving this way on the sphere, it goes from 0 to 6. Now, what about angle phi? Now, this is going to be kind of interesting. So the way angle phi works is that imagine that you're starting at the z-axis and then you are going along over here and then you're going all the way to the bottom. But you stop at the bottom. You do not go all the way back around. Otherwise, you're going to like double count some points, which you don't. So over here on the top, the angle with the z-axis is 0, right? Because the point is on the z-axis. So right here is 0. Then over here it's going to be pi over 2. And then over here is going to be exactly the opposite to the z-axis. So that's going to be pi. So the angle here goes from 0 to pi. But what about theta? So theta is like the revolution all the way around, right? Whatever this theta is going to be like the angle, right? And so it's just going to be like that, right? They're going around. So theta is going to go from 0 to 2 pi for the whole sphere. Okay, now let's look at this example. This is a cone, and so it's just bounded below by the cone and above by that sphere. So the cone doesn't extend all the way, right? Because it's bounded above by the sphere. So the sphere, it's going to be this part, right? That's going to be the upper bound, and the cone over here will be the low bound. Okay, so what's happening here? So first of all, rho will change from 0 to when we are on the sphere, and this sphere is x squared plus y squared plus z squared equal 4. So that's going to be 0 to 2, right? Because the radius is 2. What about the angle phi? Well, the angle phi is the angle with the z-axis. Okay, when we are on the z-axis is 0. When we are over here, that angle, because the cone equation is phi equals pi over 3, so pi over 3 is like your angle, the phi is going to change from 0 to pi over 3. Theta here goes all the way around again, so that's just going to be 0 to 2 pi. Okay, finally, how do we set up the limits over a region between two spheres? So you got two spheres. One of them, the inside one, has radius 3, and the outside one has radius 5. But it says first octant. So first octant means it's not the whole thing, but really 1/8 of it, because first octant means that x, y, and z are all positive. Okay, that's so whenever you see this first octant, I want you to remember that both phi and theta are going to go from 0 to pi over 2. But I'm jumping a little bit. So first, let's talk about how does rho change. So if you are over here, that's radius is 3, and then if you're over here, that's going to be radius 5. So this is going to be right here. So that if you are inside, it's 3, and the outside is 5. So it's just this part, right? So this is going to be from 3 to 5, 5 on rho, because it has a hole inside. There's nothing inside. It's only from here to here. Okay, what about phi and theta? Why are they only from 0 to pi over 2? So if you're over here on the top, your angle with the z-axis is 0. And then if you move over here, right, and stop, this is where you are perpendicular to the z-axis, so your angle is pi over 2. So phi goes from 0 to pi over 2 in the first octant. What about theta? Well, theta is going to be like 0 over here, right? So remember the theta is like a revolution around. So this is going to be 0 over here, but then it's not going to go all the way around because we are bounded by the first octant. So here it's like perpendicular to the x-axis. So that's going to be pi over 2. So this is going to go from 0 to pi over 2. Oh, this one's supposed to be pi over 3. Okay, now that's better.